Mercedes-Benz, the German automaker synonymous with luxury and engineering prowess, has been quietly tinkering with something that could redefine how we power electric vehicles, EVs, solar paint. This isn't just a shiny new finish to make your sedan pop. It's a photovoltaic coating that turns a car's body into a rolling solar panel. Imagine cruising down the highway, sunlight hitting your hood, roof, and sides, and instead of just baking the interior, it's juicing up your battery. It's a bold idea, and if Mercedes pulls it off, it could shake up the EV landscape, offering a glimpse into a future where plugging in becomes optional for some drivers. What is solar paint, exactly? Let's break it down. Solar paint isn't paint in the traditional sense, like the glossy stuff you'd pick out at a dealership. It's a thin, high-tech photovoltaic material that generates electricity when exposed to sunlight. The concept isn't entirely new. Researchers have been playing with solar coatings for years, but Mercedes is taking it out of the lab and slapping it onto cars. The goal? Coat an entire vehicle with this stuff and let it soak up the sun to power its electric drivetrain. The numbers they're throwing around are impressive. Picture a mid-size SUV, say, something like their EK SUV, covered in this solar paint. In a place like Stuttgart, Germany, with its mix of cloudy days and moderate sunshine, Mercedes claims it could generate enough energy to drive 12,000 kilometers, roughly 7,456 miles, per year under optimal conditions. That's not chump change. It's about the average annual mileage for many drivers. Now, move that same SUV to a sun-drenched city like Los Angeles, and the output could climb to 20,000 kilometers, 12,427 miles. For context, the average American drives around 13,500 miles a year, so in a sunny climate, this tech could theoretically cover your daily commute without ever needing a charging station. That's the dream, at least. The paint itself is a marvel of engineering. It's only 5 micrometers thick, thinner than a strand of human hair, which is typically 50 to 100 micrometers, and weighs a feather-light 50 grams per square meter. Compare that to traditional solar panels, which are bulky, heavy, and rigid, and you start to see why this is a big deal. It's applied as a paste-like layer, then sealed with a special nanoparticle-based topcoat that lets 94% of sunlight pass through to the photovoltaic material underneath. That topcoat isn't just for show, it protects the system while maximizing energy capture. Mercedes says the paint achieves a 20% efficiency rate, meaning it converts 1/5 of the sunlight it absorbs into usable electricity. That's on par with many commercial solar panels, which is no small feat for something this thin and flexible. What's even cooler? The materials. Unlike conventional solar panels that lean on silicon or rare earth elements like indium and gallium, this paint uses abundant, non-toxic alternatives. That slashes production costs, sidesteps supply chain headaches tied to scarce resources, and makes recycling a whole lot easier. Sustainability isn't just a buzzword here, it's baked into the design. How it works on the road. So, how does this translate to driving? The energy harvested by the solar paint feeds directly into the vehicle's high-voltage battery, the same one powering the electric motors. It works whether you're zipping through traffic or parked at the grocery store. On a sunny day, every minute your car spends outside becomes a mini charging session. For EVs, range anxiety is a real thing. Drivers obsess over how far they can go before the battery dies. Solar paint could ease that worry, trickling in extra juice to stretch your range or even replace plug-in charging entirely for short trips. Take a practical example. The daily commute. If you're driving 30 to 40 miles round trip, pretty standard for a suburbanite, this tech could, in theory, keep your battery topped off in a sunny region, assuming you've got a big enough surface area and decent weather. Park it outside your office or in your driveway, and it's sipping sunlight all day. In less sunny climates, it might not fully replace charging, but it could still cut down on how often you need to plug in, saving time and money. Mercedes hasn't said which models might get this treatment first, but you can bet they're eyeing their electric lineup, the EQ series. A larger vehicle like the EQS SUV, with its sprawling roof and sides, would maximize the surface area for solar capture. Smaller cars, like the EQB, might not generate as much, but even a few extra miles of range could make a difference. The tech behind the magic. The science here is fascinating, even if it's still a bit hush-hush. Mercedes has partnered with researchers and tech firms. XAI's influence might even be lurking in the background, given their knack for cutting-edge innovation, to refine this tech. The photovoltaic layer is the star of the show, but it's the top coat that's the unsung hero. That 94% light transmission rate is key. It ensures the solar cells beneath get enough photons to do their job. Nanoparticles in the top coat scatter light just right, boosting efficiency without compromising the car's looks. After all, this is Mercedes-Benz. No one's buying a car that looks like a science experiment gone wrong. The 20% efficiency is a standout figure. Traditional silicon solar panels often hit 15 to 22%, but they're thick and static. Thin film solar tech, a closer cousin to this paint, usually lags at 10 to 15%. Mercedes hitting 20% with something this lightweight and versatile suggests they've cracked a tricky balance. The lack of rare earths is another win. Those materials are pricey, environmentally messy to mine, and geopolitically dicey. By using common elements, Mercedes is betting on scalability and sustainability, which could give them an edge as EV demand skyrockets. Applying it to a car, though, isn't as simple as grabbing a spray gun. Vehicles aren't flat like solar panels, they've got curves, creases, and contours. Coating every inch evenly, from the hood to the rear bumper, is a manufacturing puzzle. Mercedes says they're working on it, testing prototypes to see how the paint holds up on complex shapes. Durability's another question. Cars face rain, road salt, and the occasional door ding. The top coat has to shrug off those insults while keeping the solar layer humming. So far, they're optimistic, claiming test results have exceeded expectations, but they're light on specifics. That's typical for early-stage tech. Big promises, few hard details. The bigger picture: EVs and solar power. This isn't Mercedes' first dance with solar. Back in the day, they experimented with solar panels on concept cars, like the 2011 Vision EQXX, which used roof-mounted cells to add range. Those panels were clunky, though, limited to flat surfaces and not exactly showroom-ready. Solar paint takes that idea and runs with it, spreading the tech across the whole vehicle. It's a natural evolution as EVs become mainstream and automakers hunt for ways to stand out. The timing's spot on too. Global EV sales are booming. Over 14 million electric cars were on the road by 2023, and that's climbing fast. But charging infrastructure isn't keeping pace, especially outside dense urban areas. Solar paint could bridge that gap, giving drivers a buffer against spotty grids or long road trips. It's not a silver bullet. Cloudy days and northern winters will crimp its output, but it's a step toward energy independence for EVs. Compare it to competitors. Tesla's tossed around solar ideas, like the Cybertruck's optional solar tonneau cover, but it's niche and add-on, not baked into the design. Toyota's Prius Prime has a solar roof option, generating a few miles of range daily, but it's small scale. Mercedes' approach is more ambitious. Whole-body solar harvesting could blow past those incremental gains. If they nail production, it might pressure rivals to follow suit or risk looking outdated. Beyond cars, this tech could ripple into other fields. Buildings, drones, even wearables, any surface that sees sunlight could become a power source. Mercedes isn't saying much about spin-offs, but the potential's there. For now, though, their focus is clear. Make EVs more self-sufficient and appealing to buyers who dread range anxiety or high electric bills. Challenges and reality checks. Let's not get too starry-eyed. There's a long road from prototype to production. For one, efficiency drops in the real world. That 20% figure assumes perfect lab conditions, full sun, optimal angles, park under a tree or drive through a rainy week, and output tanks. Geography matters too. Stuttgart's 12,000 kilometers sounds great, but in Seattle or Scotland, you'd be lucky to hit half that. It's a supplement, not a replacement, for traditional charging in most places. Cost is another wildcard. Mercedes says the materials are cheap, but scaling up production, coating millions of cars, could still jack up prices. Will they pass that on to buyers, or eat it to stay competitive? Luxury brands like Mercedes can afford to experiment, but mass-market EVs need razor-thin margins. Durability's a concern too. 5 micrometers is thin enough to worry about scratches or wear over time. Repairing or replacing it could get pricey, especially if it's integrated into the car's structure. Then there's the design hurdle. Cars aren't just functional, they're statements. Solar paint has to look good, not like some matte, utilitarian blob. Mercedes swears it won't compromise aesthetics, but we'll believe it when we see it on a gleaming S-Class. Regulatory hurdles could slow things down too. Automotive safety and emissions rules might need tweaking to greenlight this tech. And let's talk output. A mid-size SUV might have 5 to 6 square meters of usable surface area, roof, hood, sides. At 20% efficiency and peak sunlight, about 1,000 watts per square meter, that's 1,000 to 1,200 watts max. In reality, with angles, shadows, and weather, you're looking at a fraction of that, maybe 200 to 300 watts averaged over a day. For a 75 kilowatt-hours battery, that's a slow drip, not a flood. It's useful, but don't expect to ditch your charger entirely unless you barely drive. What's next? Mercedes isn't spilling the beans on a timeline, classic corporate coyness. They've got prototypes rolling, and the tech's advanced enough to brag about, but mass production could be years off. The auto industry moves slow. New features take time to refine, test, and roll out. If they debut it on a high-end model like the EQS, It might hit showrooms by 2027 or 2028, assuming no big snags. From there, it could trickle down to cheaper EVs as costs drop. The implications are tantalizing. Imagine fleets of solar-painted delivery vans or taxis, sipping energy all day in urban sun. Or rural drivers, far from chargers, relying on their car skin to keep going. It's not a revolution, batteries and grids will still rule, but it's a smart evolution, blending renewable energy with mobility. For Mercedes, it's a flex of innovation muscle. They've built their brand on cutting-edge tech, from the first gasoline car in 1886 to today's electric push. Solar paint fits that legacy, marrying luxury with sustainability. If it works, it could lure eco-conscious buyers and give them bragging rights over Tesla's flashier gimmicks. Final thoughts. So, what do you think? Solar paint sounds like sci-fi made real, a car that charges itself under the sun. It's not perfect, and it won't kill off charging stations anytime soon. But it's a glimpse at where EVs could go. More range, less hassle, greener vibes, all wrapped in a sleek Mercedes package. The road ahead's got bumps, technical, financial, practical, but if they pull it off, it's one more reason to keep an eye on Stuttgart. Would you buy a car with this tech, or is it still too pie in the sky for you?